Hello everyone. Today I will be explaining everything there is to know about sonar. Sonar stands for sound, navigation, and ranging. Sonar can be used to locate submarines, map the ocean floor, or find schools of fish. Now, what is sonar? Sonar is a technology that utilizes sound waves to effectively see underwater by listening in on the movements of things underwater. Why is this necessary? This is necessary because light gets distorted in the water, and radar also doesn't work because the waves lose strength quickly in the water. So without sonar, much of the ocean would still not be known by humans. There are two different types of sonar, active and passive. Both serve unique purposes from each other. Active sonar sends out a sound wave and listens to how long they take to bounce back. This method is used to map out the sea floor, locate submarines, and find fish. Passive sonar works by simply listening to the sounds underwater. This method cannot accurately locate where sounds come from without multiple to triangulate the location. Sonar works by first having a device called a transducer send out a sound wave called a ping into the water. Then the sound wave travels through the water. When the ping hits an object, a fish, a submarine, or the floor, for example, it bounces back towards the sonar system. Once the sound wave bounces back, the transducer calculates the time it took to go out and come back again. Now, the Doppler effect also plays a role in this system. For anyone who doesn't know, the Doppler effect is the change in frequency based on the movement of the source. When the source moves towards you, the pitch will be higher. When the source moves away from you, the pitch will be slightly lower than its original source. This is relevant to sonar because by measuring the change in frequency as well as the time, we can detect things like the distance and tracking of moving submarines and whether or not schools of fish are moving, and also the speed and direction of ocean currents. The history and development of sonar is a story of scientific discovery and wartime necessity. The roots of sonar date back to 19th century experiments on sound and water. Notably, the invention of the hydrophone, which could hear distant sounds without being in direct line of sight, and the underwater bell, which produced sounds that could be picked up by the hydrophone underwater. In the 20th century, submarines are becoming a bigger threat, and the need for their detection. In the 20th century, submarines were becoming a bigger threat, and the need for their detection prompted research into different methods, which resulted in applying what they knew about sound into the research. In 1915, the first widely considered practical sonar device was invented by Paul Langevin, a French physicist, and Konstantin Cholowsky, a Russian engineer. They used quartz crystals which could turn electrical signals into high-frequency sound waves and vice versa. By sending these pings out and measuring out the echoes that returned, their system could determine the approximate distance of the submarines. The first name for sonar was ASDIC, Anti-Submarine Detection Investigation Committee, first called that by the British, and they would later change the name to sonar, named that way by the Americans. Between the periods of World War I and World War II, researchers worked on improving the accuracy, range, and reliability of sonar systems. And during this interwar time, Germany explored passive listening devices. It is during this time the British would put sonar systems on most naval ships. and discover that temperature could affect the readings of sonar by affecting the speed and bending the sound waves through the different temperature layers. To account for these changes, future sonar would be equipped with temperature sensors and software to account for these effects. World War II breaks out, and it marks the first large-scale operational use of sonar technology, as it is an essential anti-submarine tool. And it is during the war that sonar is split into two main types, active and passive. Additionally, it is around this time the Doppler effect was applied to determine whether a submarine was moving towards or away from the listener. After the war, people began seeing sonar used in more scientific and civilian ways, including marine biology, search and rescue, navigation, and fishing. Despite constant refinement, sonar still has a couple limitations today, including noise interference due to the rain, waves, and marine life. High-pitched sonar can result in clearer images, but has limited range compared to low-frequency sonar that has further range but lower quality images. Interference with marine life, as high-intensity sonar can harm marine life, which is why there are regulations on sonar operation areas and times. Future improvements to sonar technology can include using AI to recognize different echoes and differentiating between landscape, fish, and submarines more efficiently, sonar that automatically adjusts to ocean conditions like rain and other weather events, and higher quality images of the ocean floor.